Okay, welcome back. We're talking about having a big thing trying to fit into a small thing. And so it doesn't really like this. And so there is a way you can tell it, look, I fully understand the consequences of what I'm doing. Please do it anyway. And it's called cast, the cast operator. And the way you do that is immediately before the big thing, you put in the data type you want to convert it to. So I'm going to go here and basically just type in with parentheses, I'm going to type in int like that. And what that'll shut it up. And they're going, well, okay, I mean, you said you understand the consequences, so okay, whatever, I'll do it. And what it does, it takes a knife and slices off the part that won't fit and puts the parts that do fit in and doesn't even tell you what it did. Okay, so the cast operator is kind of cool. It's just whatever you want to convert it to. You just put that data type in parentheses and you're off and running. Okay, on page 67, they talk about mixed integer operation. Now, this is kind of strange among programming languages, so it's kind of sort of unique, kind of. And that is, while things are being done in math, for example, if I want to combine age plus, I'm going to have to, okay. If I go here and say, I'm running out of things to say, I'm going to say double is equal to, I don't know, junk 2, because I'm running out of things to say. Junk 2, I'm sorry, double junk 2 is equal to age plus tax rate. Okay? So there's two different data types here, right? One of them is a double and one of them is an integer. So what it's going to do, it's going to convert them so they're all on the same data type before it does the math. So behind the scenes, it tries to level the playing field. Instead of trying to add two things like that, it takes and goes, eh. So let me show you an example of where casting comes in. So if I doing some integer division. So I have an integer, I don't know, kumquat is equal to 32. And another integer, I don't know, wombat is equal to 7. And I want to divide the two of them together, but I want the fractional part. So I'm going to make it a double. So this is, I don't know, junk 33. I have no idea how many times I've used junk. And I just say, kumquat divided by wombat. And that should work, right? I mean, I'm told it I want it to be a double. System out. Print L in. Junk 33 is junk 33. So let's give this thing a whirl, see what it does. And it says junk 33 is 4.0, so it did not do what we wanted to do. So in order to make this work, I have to put a cast operator in here. I have to change one of these to double so that they'll line up. Make one of them double, it'll make the other one double, right? Okay, so let's try this again. There, finally. And it's 4 point blah, 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 which is the correct answer. Now, there's a thing called a constant. Most people call them constants, but the key word is not constant like a lot of other languages. I want to have something that I'm going to be using over and over again inside my application. So in this particular case, in this one rare instance, I'm going to create a variable outside of the method and put it into the class. Okay, just bear with me. There's only a few rare scenarios where this thing works. Now I want this thing to be like tax rate, okay? But so I'm going to say double. And then I'm going to say, I'm going to take this thing out in full uppercase. Tax rate equals 0.0825, like that. Okay. Well, first of all, I can't use camel case here because everything is uppercase, right? So I can't really see what that word is. So I'm going to use an underscore, because remember, underscore is one of the ones that is legal. And then I want to tell this guy is final. Okay, final. I probably should also make it public, but that really wasn't what I was trying to show you. So Final means this is a constant, which means once it gets assigned here in line 15, you may not ever change it again, which is kind of cool. Now, the reason why I would do this, because you might think, well, okay, fine, I understand what you're doing, but I don't understand why I'd ever want to do this. Well, let's say that you were anticipating that the state sales tax to change in your area, but inside your application, you apply tax in like 14 different locations. Well, if you put this in here at line 15 and the state does change its taxes, its sales tax, all I have to do is go to change line 15, make that change, and then poof, all the rest of the references to that automatically get changed. So that's the reason I want to do this, is that it's a significant thing, in this case a significant number, which may typically doesn't change during the running of the application, but occasionally it might change for some other reason, like they change the tax rate for what state you're in. Okay, so that's the reason why you want to put something as final. Okay, and of course the naming convention here is everything is in uppercase. Some people call this screaming caps because you're shouting. And because I can't use camel because there are no humps, I use the underscore instead. Okay, so on page 70, they talk about the string class. Now, I look at line 28. It is somehow different than the rest of the variables, isn't it? Well, can you spot what the difference is between that and all the others? Well, first of all, what color is the word int and double and char? Looks kind of blue. What color is string? It ain't blue. What about int, double, and char? Are those in lowercase? Yes. What about string? Is it uppercase? No. Yes, it's uppercase. Okay. So string is not a primitive data type. Okay, it is a class. All right. So string first name equals Bob. Let's just go through this. So strings are class objects, okay? And because of that, a string, remember objects have, when we talked about it in the first chapter, we talked about it like an employee object. An employee object has lots of attributes, like, what's the employee's first name and last name, and lots of actions like calculate their pay and fire them, and, those kinds of things. So since string is, first name is an instance of the string class, I should be able to just type first name dot, and boom, I get all these things that class instance can do for me. Okay, kind of makes sense. All right, so that means they have, by the way, there's some kind of cool symbols here to describe the difference between objects and methods here, but we don't have hardly any methods. But anyway, so dang it, come on, cursor. Anyway, I just wanted to be able to show you that when you hit dot and there's a 10 gazillion things, that means you're talking about a class, not a data primitive. Okay, so let's look at some of the common methods, because that's one heck of a lot of stuff, and I certainly ain't going to ask you to memorize all that stuff. So here's some ones that I use a lot of. So character at. So I want to know what's the fifth character in the string. The length tells me the length of the string. And I want to convert it to lowercase. I want to convert it to uppercase. Okay, kind of cool. Those are very common ones. Okay, now that's basically all I'm going to get to on this, because trust me, we're going to be using strings a lot in a lot of more demos. So it's probably okay for me to just keep going. And keep going I am. On page 76, they talk about the scope of a variable. Okay, so inside this set of curly braces, let me get rid of this so I don't have any problems here. So inside this set of curly braces from line 20 to line 52, I created quite a few variables, didn't I? Now, up here, I have this guy at a different indentation level. Can't you see that guy's indentation level is different than that guy's indentation level? So the scope is all about who can see that variable. And the way it works is that basically when it's created at one level of indentation, it can see, other people can see it on the same indentation and further indentation to the right. Okay, now just kind of visualize what I'm talking about. So if I create a variable at this indentation, you can see it at that level and deeper, but I can't go backwards, okay? I can't go backwards. All right. So a top level variable, like we did on line 15, can be seen by all the lower level ones, like inside the main. So, for example, the tax rate thing. I'll tell you what. Let me just comment this out to kind of show you what I'm talking about. So, here's tax rate. Remember, I made that guy a constant, so I can't change its value. Tax rate. And then over here, tax rate. Cool. All right. Yeah, well, doggone it. Okay, fine. Don't worry about what I just did. What I was trying to get you to is that, okay, now we have these things called tax rate, which allows me to switch these things out. So now, if I could use it 15 times, all I have to do is just change it once at the top, and presto changeo, all of my changes have been made. Okay, and because it has higher scope, I can see it inside that second indentation level, because it was created indentation level up here. I can use it in an indentation level down to here. Cool beans. Okay, we are going to talk about scope again, so if the concept's still a little fuzzy, don't worry about it. We'll get back to it. Okay, so some people like to put all their variables at the very top of a method. Okay, that used to be the coding style. For example, back in the C and C++ days, it was perfectly okay and kind of sort of expected that you would list all your variables up front. We don't do that anymore because, first of all, line 21 might be like 5 pages away. You know, I don't want to have to go flip back and forth, you know, grab the scroll bar and go wee up at the top and find something. So it just made sense to declare variables where you use them rather than declare them all up front. That's just a style thing. Okay, so we need to kind of review about variables. All variables have 3 things. They have a name, they have a data type, and they have a specific scope. Okay, good. Now let's talk about comments one more time. So a single line comment, which is the one that I've done here, and then I can put in what's called a multi-line comment. And this starts with /*, and then you can type whatever the heck you want. You know, Mary had a little lamb. And you can do it on multiple lines, right? Okay, kind of make like that. All right. And so this is a multi-line comment. Now, I have a particular style that I use that I've been using for quite some time. Typically, when I'm looking for something, I'm probably looking for a comment, right? And so I'm trying to make the comments kind of stand out a little bit. So here's how I do it. I do it like this, and then put an asterisk in there and say, you know, Mary had a little lamb. Her boyfriend was very surprised. No. Its fleece was white as snow. Okay. And so I usually even line these asterisks up. Now that's just a style, okay? You don't have to do it that way. The only thing, this is the start and this is the end. This means nothing, okay? This extra asterisk in here means nothing at all. But I typically do that because when I'm scrolling hunting for comments, I can spot that a little bit easier. At least I can. Okay, so we have the single line, we have the multi-line, and then there's another one called a documentation type, which is this one where it starts with /**. Now, we're not going to use that at all in our programs. I'm just saying that it's there. Okay, so as usual, we're coming up on the 15-minute mark. This is probably a good place to stop. So I'll see you guys again in just a few.